All right, let's take a look at this lesson here. We're going to take a look at something called slope point form of a line. This is just another way of describing a line, and it's going to be a way of describing it mathematically. What is the relationship between the x and the y values that are represented with, in this case, it's a line, but we could also take a look at any pattern that we might have when we're describing it. So first of all, let's look at this line here, and let's look at what some of our prior knowledge is when it comes to relationships of a line. This line right here has 2 points, and it goes through the y-intercept. So let's think about graphic form or slope-intercept form, which you might have heard of in the past as well. I'm going to call it graphic form. So what is the slope of this line? Well, we can find that using the rise and the run between 2 points. Rise being 2, run being 8. Ha! Perfect. Got it. Okay, so we would know that our slope would be 1/4 in this case right here, which you may be able to see here on this graph, but it might take you a bit longer to find, and that's totally fine as well. Now, the second thing we need to know is what is the y-intercept of this line? If you look really closely here, you will notice that the y-intercept of this line is somewhere between 2 and 3, just a little bit above 2. Well, that tells us that it's not a very nice number. It doesn't go through a nice point. And so we can't really use graphic form of this for this line because we don't know what the y-intercept is. And that creates a bit of a problem when it comes to finding the relationship. But we do have some tools to use that. So let's go back and look at our three forms of an equation, namely general form, graphic form, and slope point form. General form is something where we kind of have something very straightforward. It's in just an equation. It's equal to 0. Graphic form, we're using the slope and the y-intercept. And then we have the slope point form, which is a little bit longer, but also has some nice pieces to it. And we're going to look at that one today, or in this lesson. So what is slope point form? This is what it looks like right here. Now, like every other equation, we're going to be using the relationship between x and y to as a way of representing this pattern. Okay, so we have our x value and we have our y value, and we're going to be looking at the relationship. Now, the thing that explains the relationship is these other numbers, namely m, x1, and y1, that we're going to have to glean from our line, or we can use to figure out what our pattern is going to be, and the value that we can use in our pattern as well. So let's define what we have here. Firstly, we have m. Okay, now we should remember from the previous lessons that m is the slope of the line, the rate of change, rise and run, something along those lines. So it's our slope, and we have to know how to find our slope. The x1 and the y1 are other values. This is any point along the line. Okay, absolutely any single point along the line. If we know a nice point, we can use it for our x1 and our y1. Now, there might be more than one point known, and so then we can use either one, any of the points that we know, and we'll take a look at that in the examples going forward. So let's determine the equation of this line. Can graphic form be used? No, we cannot. And the reason we cannot use graphic form is because we don't have a nice y-intercept. Very important to recognize that when we're talking about relationships and when we're talking about equations. If we don't know the y-intercept, we cannot use graphic form. So if the slope and a single point are known, okay, and this could be the y-intercept too, in fact, slope point form can be used to create our equation. Okay, and then we'll look at how we can change it into graphic form a little bit later on. Okay, so we have this line right here. We have 2 points. Okay, not sure why that one is in yellow, but we have -5, 1, and we have the point 3, 3. The slope between those 2 points there is 1/4. Okay, rise of 2, run of 8. Now, the point that we're going to use here, okay, and we actually have like 2 points, but I'm going to say let's use -5, 1. Okay, or we could use, there we go, let's bring it over here, okay, 3, 3. So we have these 2 points that we could use, either -5, 1 or 3, 3. Either one of them, in fact, is gonna could work when it create the line. And again, I'm going to show you how they both give us the exact same equation. All right, so this was what our equations are going to look like. If we take our slope 1/4 and we take our point -5, 1, we can plug the -5 in for the x1 and the 1 in for the y1, and we're going to have y is equal to 1/4 x plus 5 and then plus 1 afterwards. You'll notice that the x plus 5 is in brackets there. Now you also notice that I changed the sign or the positive negative on the 5 because of what we need to do. So this is one way of creating our equation. The second way is we can use the 3, 3. So you'll notice again, like the x is now -3 instead of +3, and then we're adding 3 at the end. So these are two different equations, which actually happen to be the same equation, just with different numbers put in there. All right, now I want to show you why they're the same, and so we'll convert both of them into graphic form and show that it's the exact same equation when we simplify. So our first step here is we're going to take this one, and I'm going to multiply the fraction there, the 1/4, through the brackets, and it's going to look a little bit like this. 1/4 times x is 1/4 x, and 1/4 times 5 is 5/4. Now you'll notice that we have two constants here. We have the 5/4 and we have the 1. And they're both positive, so we're going to combine them together, and we're going to get that y is equal to 1/4 x plus 9/4. Now 9/4, you might be wondering, like, okay, that's kind of a weird number. It's an improper fraction, that's fine. We can change it into a decimal, and it's 2.25. So here's our equation in graphic form. Now you'll notice the slope is 1/4, okay, rise of 1, run of 4, and our y-intercept is 2.25. Does it look like our line is going through 2.25, okay, as a y-intercept? Yeah, it sure does. Okay, so we know that we've probably done an okay job with our line if we're getting that kind of value in return. Now let me show you the other one. So here is the other equation that we came up with, and let's do the same thing. Let's multiply the quarter through, okay, and so we get this here, 1/4 x minus 3/4 plus 3. Well, let's combine those two together. When we combine -3/4 and 3, we're going to get positive 9/4. Notice the similarity? Yeah, it's also 2.25. So both of these forms of the equation actually are the exact same. They're just using a different point as a reference. And that's important that we always consider that we're using a reference point, okay, to give us kind of a way of starting our relationship. And then the slope is going to give us that how the pattern is changing. In this case, the pattern is changing with a 1/4, rise of 1 or run of 4. Now, we can also use this to graph a line. So if we have something in slope point form, we can graph the line with it. And we have to figure out what is the slope and the point that we're starting with. Now, in this case here, the slope is always the one or the value in front of the bracket. So that's -5/1. I'm going to say -5/1, even though it just says -5. So that way it gives us the rise and the run in this case. And then the point that we're going to use is -4/4. Okay, and that comes directly from the equation that we have. Okay, so -4/4 comes directly from that equation. First thing we need to do, plot the point. There is -4/4. Okay, we plot that on the graph, and that is our reference point. That's our starting point for this relationship. Then we use our m value, our slope, to go down 5 and over 1. And it comes to our second point. In this case, it happens to be -3, -1. Okay, this is just a second point on our pattern or our relationship. And because we now have two, we can draw a nice straight line through them. And this is now graphing our line. So we can both create an equation and we can graph an equation based on slope point form. All right, let's take a look at a couple of examples, which will hopefully help you to create equations and then also to change them into graphic form. So I would recommend that at this point you have a piece of paper and try to come up with the equation of this line. And you can use, you can work with a partner maybe or something along those lines as well. Gladly pause the video and then come back when you think you have the answer. So let's take a look at this answer here. We have 2 points. We have -5, 3, and we have 3, -3. And we want to try to figure out what the equation of this line looks like. Well, firstly, okay, we need to know what our slope is. Our slope is always our rise over run. We have 2 points, so we can use them to solve. And when you do that, you're going to find that the slope is -3/4. You might have gotten -6/8, but remember to simplify that because we always want to make it the simplest fraction possible. Now, the point that you're going to use will depend on which one you want to use. Did you want to use -5/3, or did you want to use 3, -3? Or you might have looked at this graph and said, hey, look, 0, 1. Actually, no, sorry, -1, 0 is also a point. Could have used that as well. Whatever point you decide to use, you're going to come up with the same equation. Now, let's plug it in, and you should have gotten something that looks like either this, okay, as an equation, or this. Okay, there's 2 different versions depending on which point you happen to use. And both of them are correct. Okay, so both of them are correct. Just remember to make sure that the x value you switch the sign. Okay, so if it's negative in the point, it's positive in the equation. And if it's positive in the point, it's negative in the equation. So make sure that we've done that. All right, now, next step, can we convert it into graphic form? So it doesn't matter which one you chose. Okay, give it a shot. Try to convert it into graphic form. Multiply the fraction through the brackets, and then add the constant onto it. I'll give you a minute, and then come unpause and try to figure out if you got it correct. All right, now it doesn't matter which version you use, you should have gotten y is equal to -3/4 x minus 3/4. Now, if you have that as -0.75, that's fine as well, if you like to use fractions as well. But we want to try to make sure we're always using exact numbers. So 0.75 works. It's a nice fraction. But if you have to round a fraction, probably try to use, or round the decimal, try to use the fraction. Now, if you look at the graph there, you'll notice that that line crosses the y-intercept right around -3/4. So it's a little bit, it's between 0 and -1. So that means that we probably did something right. It's a good thing. And well done in coming up with your graphic form. All right, here's another one. Let's try to create the equation of this line. We have the points -3, -5, and the point 1, 1, and go. Okay, now hopefully you're able to figure out the equation of this line here. We know our slope, 3/2. Hopefully you're able to come up with that. And then we also have 2 different points that we could use as a part of this equation. So you should have either this one here, y is equal to 3/2 x plus 3 minus 5, or you might have this equation here, y is equal to 3/2 x minus 1 plus 1. Now, both of these work. Remember that we need to switch the x value in our equation. So instead of having a -3, we have a +3, or instead of having a +1, we have a -1 for our equation. Now, second part, can we change this into graphic form? Okay, so give it a shot. Everything, it doesn't matter which equation you use, you're going to get the same value in graphic form. Okay, so hopefully you have it, and you should have something that looks like this here, 3/2x minus a half. Now, 3/2x is going to be the same as 1.5, and negative a half would be the same as -0.5. So if you have those 2 values in there, well done, you've done it correctly. Make sure, again, to do some practice in getting that figured out. All right, let's look at the other way. Let's graph out this line. Okay, so create just a simple little piece of graph paper, and then come up with a graph for this line. All right, let's take a look. Now, your graph paper might not be quite as simple or basic as mine, or as complicated as mine either, but let's take a look at graphing this out and what does it look like. The first thing we have to understand is that we're going to use our reference point. And in this equation, our reference point is -4, 2, right there. Okay, there's our reference point. Now that's where we're starting. That's one of the values on this pattern, and then we're going to use our slope to find the next pattern. Our slope happens to be 1/3, so that means we're going to rise 1 and run 3, right to that point there, which happens to be at -1/3. Now we could do it again and go rise 1, run 3, rise 1, run 3, and goes over and over and over again as we come up with points that are along the line and that satisfy this relationship. but we only need the 1 in this case here, because once we have 2 points, we can draw a nice straight line through, and this gives us our equation of the line. Okay, so that there gives us a nice way to graph it. Let's try one more and see how you do, and then I'll come back and we'll figure out if you did it correctly. All right, this other example here, we have a slope of -8/3, and we have a point of 1, 6. So let's plot that point 1, 6, that's way up there, up on the top of our line, and then use our slope to come up with our second point. So -8/3 means we go down 8 to right there, and a run of 3. Now remember, the run is always positive, it's the rise that is going to be negative, unless we go backwards. And once we have these 2 points, we're going to draw a line through, and this gives us the graph of our equation. So remember that all we need is a point. That's a reference point. It's somewhere along our line. It's going to be in that equation, and then use the slope to come up with our second point or second value so that we can determine what our equation looks like. All right, all the best as you work through your stuff. Hopefully this video has helped you, and please be ready to reach out if you have any questions on slope point form of a line.